Hi everyone, in today's tutorial we'll be looking at literals, operators and operands. Okay, so what is a literal? Well, a literal is a value written in code. So I'll just open up an example and show you. Okay, this is the simple Hello World program. So what a literal is a literal is a value written in code, which is exactly this. What literal does is it's not a variable because you don't declare it. It's a all it is it's printed out to the user just as it's written in the speech marks. So the hello world itself is the literal, and that will be printed out to the user. I'll just show you now. So yeah, that hello world is the thing printed out, and that's the literal. So yeah, okay, so I hope I've given you a brief understanding about literals. So moving on to operators and operands. Okay, so often in programming, we are given data to make calculations on, but as we have the ability to code, we can simply make a program to do it for us. So first of all, an operator is a symbol that represents a specific action. These allow you to these allow us to manipulate numbers and text in a more advanced way. So a an operator is something like addition, subtraction, multiplication, and all of these mathematical tools that we can use in our program to perform calculations on. So I'll just make a quick example. Okay, so um, let's say I want to add two numbers together. So what I can do is I can make two variables to store the two numbers, and then I will output the answer to the user. So let's say a num and b num. And as we always do as good programmers, is that we assign the variables straight away. And what I'll be doing, I declared them as integers just to make it simple for us today. And what I'll be doing with these is I'll prompt the user to input two values for each of them to be able to be calculated on. So let's go. First let me just write a comment. Two variables to store our two numbers from the user. Okay, in the main function, what we can write is we can output using the character output, which is from the input output stream, which is an external library, if you can remember from the last tutorial. And we can say please, don't forget speech marks, please enter a number. Then we can end the line, and then we can take in this number using the character input, and then we'll store it as a num. Don't forget the semicolon. Okay, let's write a quick comment and say prompting the user to input a number for us to store in our first variable. And then we'll do the exact same thing again. We'll say cout, but this time we'll say please enter a second number, and then end the line. Then cin, then we'll store, oh, that one's wrong, do apologize. Programs will always make mistakes, and we'll store that as bnum. And this is to store the second number before it's added to the first. And if you haven't realized already, what we forgot to do is to create a variable for the answer to our addition with the two numbers. So let's say int sum equals 0, and what this variable will do is this variable will store the sum of the two numbers. That's why I called it sum. Okay, so moving on. Now we need to actually perform our calculation. So a way we can do this is we can use the sum variable, and we can say sum, and then we can use an equal sign and say a num, and then as we're adding these numbers we need to use the actual plus sign or addition sign, and then bnum. Okay, so now all we need to do now is we need to output it to the user. So we can say cout, then the sum of the two numbers you entered is, then we can go here and we can say sum, and then we can end the line. Okay, so let me just make a comment here and say the calculation of the two numbers, and telling the user the sum of the two numbers. Okay, so just referring back to this line, we can, even if the sum is in a variable, we can still add it to be printed out just like this, but we just need to add two of these arrows again, just so it's not joined in here, which causes a lot of errors. So let's save it, let's build it and see if we have errors, and we do. Oh, yeah. Okay, alright, so let's save that again. Let's build it. It looks fine. And then let's run it. Okay, please enter a number. I'll do some very easy numbers, 5, and 5. So after we should get 10 at the end of this. Yep, and the sum of the two numbers you entered is 10. So as we can see, that works perfectly. So now we can move on to advanced calculations. So what we can do various things such as addition, subtraction, multiplication, division, and modulus, using the modulus operator, which returns the remainder of an action that gives a remainder, basically, such as like 10 divided by 7. And how we can do this is we can add we use the percentage sign. So let's say here we use the percentage sign, and then we can go on and just change a little things in the program. Obviously it's not a sum anymore, so the remainder of the two numbers remain. Okay, so what we need to do is I just changed the variable names just to make it a bit simpler and relevant. So let's say we enter 10 and we say we want as we enter 10 for a num, and then we enter 2 for b num, and then it will come here and say the remainder equals 10 divided by 2, and then it will give the remainder. But as you should know, 10 divided by 2 doesn't have a remainder, so the remainder should be 0. So let's just test this and see what happens. Okay, no, I didn't change one. Oh, there you go. And let's run it. 10 divided by 2 equals 0. As we predicted, there isn't a remainder. But let's try a different one. Let's say 10 divided by 4, which will give a remainder of 2, as we can see. So there we are. Another thing I want to show you quickly is incrementation. And what incrementation does is it, depending on the position of these two operators, they can add one to the number. So let's just try that quickly. Okay, let's just do a simple number 1, and what we're expecting it to do is add 1 to 1 and then show 2. So yep, that's exactly what has happened, and it's output 2. And the exact same thing can be done with 2 negation signs. Let's do that. Save it and run it. Okay, let's put 10. We're expecting it to give us 9, and there it goes. And incrementation can be very important in big programs because it can allow you to do more sophisticated things with the data you're given. So yeah, and you can also do it after the variable. So let's try it out and say, but this thing with doing it after is that we won't see the difference in the number on this line unless we output it again. So let's try it out. But I will comment this line out just so we can see the difference. So let's save this, run it. Okay, enter a number, say 10 again. See, as we predicted, it doesn't stay